we have to assume that this is the tower of 200 meter. One stone is dropped from the tower, at the same time the another stone is projected vertically upwards. Half into 9.8, that is 4.9 t square, and we'll call it as equation 2. So equation 1 is for stone A and equation 2 is for stone B. When the distance between the two cars is 2.5 km, car B is given a deceleration of 20 km per hour square. Hello everyone, welcome to session 6 of chapter 3, Motion in a Straight Line. In the previous session, we were solving numerical problems from this chapter. So let us continue with few more problems in this session. This is Swati from Department of Physics, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. The first problem is, from a balloon which is ascending with a velocity of 9.8 meter per second. For example, this is the balloon. Consider this is a balloon. It is ascending, which means which is moving upwards with the velocity of 9.8 meter per second. A stone was dropped and it reached the ground in 11 seconds. So, from the balloon, the stone was dropped and it reached the ground in 11 seconds. So, how high was the balloon when the stone was dropped? So, what is the height, the displacement of the balloon when the stone was dropped and it reached the ground in 11 seconds? We have to find the displacement of the balloon and with what velocity did it hit the ground. The stone was dropped from the balloon. We need to find out the velocity of the stone when it hits the ground. What is the velocity of the stone when it hit the ground? We have to find out. It is also given that the acceleration due to gravity is 9.8 meter per second square. So let us now write the given data. For the motion of stone, u is minus 9.8 meter per second, because the initial velocity is taken as minus 9.8 meter per second because the motion of the stone and the balloon are in opposite direction, and t is given. It hit the ground in 11 seconds, so t is 11 seconds. How high was the balloon when the stone was dropped from it, and what is the velocity of the stone when it hits the ground? That is what we have to find out. We have the kinematic equation for displacement, that is s is equal to ut plus half gt square. Here we are not considering half at square because we need to consider the acceleration due to gravity for a freely falling body. So ut plus half gt square. So let us now substitute all the values. S equals, u value is minus 9.8, t is 11 seconds plus half, g is 9.8 and t is 11, so 11 square. So after simplification we get s is equal to minus 107.8, that is minus 9.8 into 11, that is minus 107.8 plus half into 9.8 into 11 square gives us 592.9. So plus into minus is minus. We need to subtract these two and we get the displacement is 485.1 meter. That is the value of S, which is nothing but the height of the balloon. When the stone was dropped from the balloon was at a height of 485.1 meter. And we also have a formula, the kinematic equation, that is V is equal to U plus AT. For a freely falling body we are writing now, so it is V is equal to U plus GT. So U is minus 9.8 again, and the value of G is, that is acceleration due to gravity, 9.8 into time. So we have to find out the velocity of the stone when it hits the ground, and U is minus 9.8 plus G value is plus 9.8 and the T is 11 seconds. So simplifying this, we will get the velocity 98 meter per second. Do not forget to write the proper SI unit for any of the quantity, and hence we will get a full mark in solving the numericals. So that is our previous problem. Let us move on to the next problem now. A stone is dropped from the top of a tower which is of 200 meter. Let us assume this is a tower whose height is 200 meter. The stone is dropped from the top of the tower which is of 200 meter tall, and at the same time another stone is projected vertically upwards. At the same time another stone is projected vertically upwards from the ground with a velocity of 50 meter per second. The velocity of the stone which is vertically thrown, which is upward thrown, that is 50 meter per second. Find when and where the two stones will meet. We have to assume that this is the tower of 200 meter. One stone is dropped from the tower. At the same time, the another stone is projected vertically upwards. When the two stones will meet and where at what time the two stones will meet. We have to find out. Let us consider two stones, one as stone A, the other one as stone B. So let stone A is dropped from the top of the tower. From the top of the tower, let us call it as stone A. It is dropped from the top of the tower, and at the same time the stone B is projected vertically upwards, and it is projected vertically upwards with the velocity of 50 meter per second. So let two stones meet at a height x from the ground. Let us consider this is the point of their meeting and we'll call it as x meter. So let them meet at this point, and which is at x meter from the ground after t seconds. So for the downward motion of stone, the initial velocity u is 0 and g value is 9.8 meter per second square. That is, acceleration for the freely falling body is always positive conventionally. So g is 9.8 meter per second square and s is 200 minus x. Why it is 200 minus x? The tower is of height 200 meter and they are meeting at the point x. So x is nothing but the distance from the ground to the point of meeting. So it is 200 minus x is the point of stone A. The displacement where both the stones will meet is 200 minus x. We have s is equal to ut plus half gt square. Let us now substitute all the values. S is 200 minus x, which is equal to u is 0 plus half and g is 9.8 into t square. So when u is 0, when it multiplies with t, it will become 0 only. So it is not mentioned again. 200 minus x is equal to 0 plus half 9.8 into t square. So half into 9.8, it is nothing but 4.9. We will get 200 minus x is equal to 4.9 t square, or we can write x is equal to 200 minus 4.9 t square, and we'll call it as equation 1. This is for the stone A, which is falling from the top of the tower. Let us now analyze the same for stone B, which is thrown vertically upwards. For the upward motion of the stone B, u is 50 meter per second. So it is given in the question only. The velocity of a stone which is projected vertically upwards, it is of 50 meter per second. So the value of u is 50 meter per second and g is 9.8 meter per second square, and s is equal to x, because from the ground the height of their meeting is x meter is what we considered. So again we have s is equal to ut plus half gt square is the kinematic equation, ut plus half gt square. Here the body or the stone which is projecting vertically upwards. So sign convention for acceleration for the body which is going opposite to the gravity is always negative, and hence we will consider here g as minus d, that is minus 9.8 meter per second square, which means here we have to write this same equation with negative sign, ut minus half gt square. So s is equal to u is 50 and t as it is retaining minus half, g is 9.8 t square. Why minus? Because the body is projecting vertically upwards, which is opposite to the direction of acceleration due to gravity. So s is equal to 50t minus half into 9.8, that is 4.9 t square, and we'll call it as equation 2. So equation 1 is for stone A and equation 2 is for stone B. Let us now simplify these by taking the difference between two equations. So by taking the difference between these two equations, s and x are nothing but the displacements. So they are same, and then they will get cancelled. So we will get 0 in the LHS, and in RHS we will get 4.9 t square, they will get cancelled. So we remain with 200 minus 50t. So we will get 0 equals 200 minus 50t. We need to find out the time period where exactly they meet. So here we will simplify for t. What do we get? So here we will get 200 is equal to 50t, and from this we can write t is equal to, this is multiplied with t and it will come to the denominator. So 200 by 50. 51s are 54s are. So t is equal to 4 seconds. So let us substitute this t in equation 1 to find the exact place or exact distance where does they meet. So equation 1 is, what is equation 1? X is equal to 200 minus 4.9 t square. So we have to let us write x is equal to 200 minus 4.9 t square is equation 1. Let us now substitute t value in the same equation. We will get x is equal to 200 minus 4.9 into 4 square. Why 4 square? Because t value is 4. And we will get x is equal to 121.6 meter, which means the distance where they actually meet from the ground is 121.6 meter. Let us solve one more problem. A car A is traveling on a straight level road with a uniform speed of 60 km per hour, is followed by another car B which is moving with a speed of 70 km per hour. In this problem, we have two cars. Car A which is traveling on a straight level road with a speed of 60 km per hour, and car B is following the car A and it is moving with a speed of 70 km per hour. When the distance between them is 2.5 km, the car B is giving a deceleration of 20 km per hour square, which means when the distance between two cars, that is from car A and car B, when the distance is 2.5 km, car B is given a deceleration, that is a retardation of 20 km per hour square. After what distance and time will B catch up with A, which means what is the exact time B will come along with car A? When the B car will catch up with car A is the question. We have two cars moving with different speeds, and when the distance between the two cars is 2.5 km, car B is given a deceleration of 20 km per hour square. So we need to find after what time and what distance they both will catch up together. So let us now write the given data. Let car B catch up with car A after traveling a distance of x kilometer. We don't know what is the distance. We have to find what is the distance they catch up together. So let us consider this point they catch up together. They meet up together. So this point let us call it as x kilometer. Since we have no idea of the distance where exactly they meet, we are actually going to find it out. So let us consider B catch up with car A after traveling a distance of x kilometer. For car A, it is given that 60 km per hour is the speed. So U is 60 km per hour, and the displacement or the distance what they travel is x, that we don't know, we have to find, and time also we have to find, and let us consider it as t now. Now we have a formula. U is equal to, that is speed is equal to distance divided by time. Distance is nothing but s and t is time, which can be written as x by t as per our consideration. Now U is 60 is known for us. So 60 is equal to x divided by t, or distance x is equal to multiply these to 60t. Let us consider it as equation 1. So now for the car B, it is given that the speed U is 70 km per hour and S is x plus 2.5. Why it is x plus 2.5? After x distance they travel, they will meet together, and already there is a 2.5 km distance between the two cars. So 2.5 plus x is the total distance travelled by car B, and hence it is S is equal to x plus 2.5 and A is minus 20 km per hour square, because it is given a deceleration. It is not acceleration, it is a negative acceleration, that is deceleration of 20 km per hour square, and hence it is taken as minus 20 km per hour square. So applying S is equal to ut plus half at square, we get the S is nothing but x plus 2.5. So substitute the same x plus 2.5, which is equal to, for car B, U is 70 into t minus half 20t square, because here though we have plus, A value is minus 20 and plus into minus will be minus. So 70 t minus half 20 t square. So now let us simplify. 2 ones are 2 tens are. So we will get x plus 2.5, which is equal to 70t minus 10t square. So substituting x from equation 1, look at the equation 1, what is x? It is 60t. So let us now substitute x value is 60t from equation 1 here. In the place of x, we are substituting 60t plus 2.5, which is equal to 70t minus 10t square. So let us now rearrange this term for further simplifications. We will get 10t square. I am taking all the terms to one side. This minus 10t square, when it gets transposed, it will become plus 10t square plus 60t already I have, and this plus 70t we have. So when it comes to LHS, it will become minus 70t plus 2.5 as it is we have, which is equal to 0. So here we have plus 60t minus 70t. So simplifying those two, we will get 10t square minus 10t plus 2.5, which is equal to 0. And from this now let us take out 2.5 common. By taking 2.5 common, we will get 4t square minus 4t plus 1, which is equal to 0. And this can be written as 4t square, splitting this minus 4t as minus 2t into minus 2t, we can write plus 1 is equal to 0, or we can take 2t common from these two terms, and this will be 2t into 2t, because 2t into 2t is nothing but 4t square. The same we will get minus 2t into 1 is nothing but minus 2t. So there will be no change, and we can write like this. And from these two terms, taking minus 1 common, we will again get 2t minus 1. So from here we can write 2t minus 1 equals 0, or 2t is equal to this minus 1. When it goes to RHS, it becomes 2t equals 1. From this we can write t is equal to 1 by 2. Which means the time is half hour, that is 0.5 hours. But we know the distance also we have to find. Or how to find this distance? From equation 1 we have x is equal to 60t. So in the place of t we can substitute this value, that is 60 into 1 by 2, which will give us 30 kilometer. So the distance travelled by the car B is 30 plus 2.5. Because in the question I have shown you already, 2.5 plus x is the distance where they actually meet. So x value is known to us now, that is 30 kilometer. So x plus 2.5 we have to find, that is 30 plus 2.5, which is nothing but 32.5 kilometer. So after traveling a distance of 32.5 kilometer, the car A and car B will catch up together, and the time taken for the car B to catch up with A is half an hour, that is 0.5 hours. These are few interesting numerical problems based on motion in a straight line concept. So in the next session, we'll meet up with another new chapter. Until then, please take care all of you. Thank you.